There's a lot of attention that has been paid to the Edwards Aquifer and talking about the Edwards Aquifer recharge zone. But nobody talks about the Trinity Aquifer recharge zone. They actually just call the Trinity Aquifer the Edwards contributing zone. What is the Trinity Aquifer recharge zone? What streams that are flowing over the Trinity Aquifer rocks are actually making their way down into the aquifer and recharging the aquifer? That's really what this dye trace study is designed to learn about. Really, a dye trace study, it's very simple in concept. You take non-toxic fluorescent dyes and put them directly into the stream and let the stream naturally carry the water into the ground. Once that dye has entered the ground, you set up a monitoring network with a series of wells. By periodically monitoring those wells, you can see how fast did it take to get there. And through that, you can really better understand the dynamics of the aquifer. A dye trace has never been done in this upper reach of Onion Creek in Hays County. So we're really dealing with new territory here. And that's really what makes this project so exciting. The Trinity Aquifer is a karst limestone aquifer, which means that the flow paths are quite fast. And as a consequence, there's less time for the aquifer to filter out contaminants. And that's an important point when you're talking about these dye trace studies. If we're showing the water flowed 1 kilometer a day, well, then maybe we might want to consider, protecting those reaches of Onion Creek where the water is going down into the aquifer, because it has implications for water quality and folks that might have wells within that aquifer. When you first inject the dye, it is really bright, really visible, and that's because you're injecting very concentrated dye at the point of injection. But once that dye goes down into the subsurface, it will diffuse out and become a lot more diluted. Just because you can't see the dye doesn't mean that it's not there. And that's really where the lab comes in. We have these little activated charcoal packs that we deploy on different wells and springs where we think the dye might be showing up from the aquifer. Over a series of days or weeks, we let water from the well or the spring flow over those charcoal packs, and any dye that comes into contact with the charcoal will stick to the charcoal. We can ship that pack off to a lab. This lab can analyze samples down to parts per trillion. So it's very small amounts of dye can be detected from these monitoring locations. The Trinity Aquifer really varies a lot. There's some regions within our district that are a lot more productive than others. Part of what we do as the science team at the district is to sort of understand that variability across the district. What regions can sustain pumping on any sort of scale? In an area like Onion Creek, where we have this surface water and groundwater connection, it also coincides with some very productive wells. So from a policy-making standpoint, you might say, this particular region could handle a little bit more pumping than maybe this other region where there's not groundwater recharge. This study really will help us better understand the aquifer. One of the best things we can do is public outreach and education and try and do the best science that we can do to better understand this groundwater resource so that decision makers and stakeholders have the best information at their disposal when they're making important decisions about how to manage this resource.